now I want to talk about the next steps for the research team after completing the interoperability research. As I showed at the beginning, we are currently in the interoperability libs milestone and finalizing some supporting libs. What I now want to talk about are the next research roadmap objectives. The first objective is to reduce the time to finality. So why is this important and what does it actually mean? So if you send a cross-chain update transaction, then the messages that you include, the transactions emitting those messages, have to be final. The reason is that the main chain in this example has to rely on this information that's included in the main chain. So it has to rely on the fact that these cross-chain messages were actually emitted on the side chain. And this can only be 100% relied on if these included transactions in the sidechain are final. So currently, in the Lisk ecosystem, or with Lisk Core 3.0, the time to finality on the Lisk main chain will be about 155 blocks on average, which is around 26 minutes. On sidechains which use less validators than the Lisk main chain, for example, only 10 validators instead of 101 active validators, this time to finality will be already quite a bit smaller. But our goal is to even reduce that a lot more. So our goal is to reduce it to less than 20 seconds. So we want to research a Byzantine fault-tolerant consensus protocol that reduces this to 1 or 2 blocks, so less than 20 seconds. And why is this important? The reason is that this would greatly improve the user experience because you have a lot faster cross-chain messaging. So currently, if you transfer tokens from the Lisk main chain to a side chain, then you would have to wait for finality on the main chain, so you would have to wait around 26 minutes before a cross-chain update could be submitted to the side chain. Now, with a faster finality, this would be much faster. So in less than a minute, you could transfer tokens from one chain to the other chain in the Lisk ecosystem. Then I want to talk about another new roadmap objective, which is providing an incentivization mechanism for relayers. As already was mentioned in a previous talk, relayers are those individuals which submit cross-chain update transactions to other chains. And when submitting a transaction, here in this example, to the Lisk main chain, these relayers have to pay transaction fees, and in return, they receive some fees of the included messages. And right now, we already have everything in place for sidechain developers to write their own custom incentivization mechanism that ensures that in any case, the relayers are sufficiently incentivized to always submit cross-chain updates to the main chain and also include cross-chain updates in the side chain. But what we don't provide yet is a default out-of-the-box relayer incentivization mechanism. And this is what we want to research. So we want to define a new SDK module which provides such a relayer incentivization mechanism. And the key benefit is here that the sidechain developers will have an easy easy-to-use default incentivization module that I guess most sidechain developers would choose. But of course, still it would be possible to customize it and to write your own incentivization mechanism. Then another new research objective is to generalize the fee system. So with the new dynamic fee system, the transaction fees are based on the byte size of every transaction. So basically, transactions pay for block space. And the transaction fee is based on its size, but also on the transaction type. So certain transactions are a bit more expensive, such as the delegate registration. but we want to offer even more flexibility to sidechain developers. So we want to research a fee system that also accounts for other resources that are consumed by transactions. One being the computation cost, the other state space. So state space, for example, if you look at the multi-signature registration, with this transaction you register a set of keys, and they are stored as part of the state of the blockchain. And this should also be sufficiently accounted for. And here the key benefit is that with this more flexible fee system, sidechains can cover even more use cases. But of course, if this is not needed, they still could go back to the more simple fee system, which is only based on the byte size of the transaction. And apart from these 3 new roadmap objectives, I'm also excited to announce a new research roadmap phase. And this one is called Blockchain Interoperability. So remember, the current phase is called Lisk Interoperability. This is about interoperability within the Lisk ecosystem. In this new phase, this is now all about interoperability with other ecosystems. So in this graphic you see Ethereum, Polkadot, Cosmos, and Cardano. And the key benefit behind this roadmap objective is that Lisk users can then, if we have this connection, Lisk users can benefit from tokens and functionality of other ecosystems, but also the other way around. Like users from other ecosystems, for example, Ethereum, could move their tokens to Lisk and benefit from low transaction fees or special sidechains that offer special functionality that only exists in the Lisk ecosystem. So to summarize, we have these 3 new roadmap objectives, which we put in a 5th milestone in the Lisk interoperability phase. And then afterwards, we also have a new research roadmap phase, which is called blockchain interoperability. And here we want to research the topic of Lisk bridges, so interoperability with other ecosystems. And we haven't decided yet on which ones. This will be part of the research, but candidates are Ethereum, Polkadot, Cosmos, and Cardano. So this was the research part for today. Thank you very much.